What's up? This is Scott with Tubase, and today we are here to talk about how we link our TouchDesigner patches to just about any music playback software. We're talking Serato, Tractor, Virtual DJ, all with Ableton Link. In this case, we are using a UI here at the top. This is a UI that I have open while I'm DJing. I actually have another laptop with the music playing over here, but let me just show you what we got going on. So up top we have our every single snare. We are putting a new pulse of light coming through. We can change the way they are formed, and it is perfectly linked in time. So as we transition any which way from song to song, tempo to tempo, they are always playing in time. I can affect the period, how fast each one lasts. We got 1 beat, 2 beats, so on and so forth. So that's how I use it on my DJ playback software. There's a lot more to what we have going on here, but we're going to keep it surface level today, and we're going to open up a different patch to kind of showcase what we have going on and what you're going to learn today. All right, so here we have a GLSL top up at the very top of the screen. It features 32 pixels representing 32 RGB LED fixtures. This sort of a method can be applied to any type of fixture. We're talking moving heads, video walls, whatever. This is just strictly a way that we can use the tempo from our music playback software to generate pulses of light that have the properties we're searching for. In this case, this is currently playing back at 120 BPM. I don't have it linked up to my DJ software here, but if I change this period over here on the left to 1, then this pulse goes by much faster. If I change the tail to 0.25, then the area that is illuminated is shorter. You'll see as we go through here, that's a short tail. And if I make it 0.8 again, the next one will be long. Cool. So we can also change the way that we sort our pixels to make it like a clap emanating from the middle of our bank of lights. The list goes on and on. It gets really complicated if you like, but for today we're going to work at this as a very basic GLSL level. So I'm just going to start from the very top, but just so we're aware of what's happening, we have a clock over here that is just purely linked up to Ableton Link, and it is pulling in the beats, the tempo, and the 16th notes. We won't even use the 16th notes today, but it is nice to have on occasion. From there, those beats generate events like this, and that event is pulled into GLSL to create our pulses. So seeing the overlay of how that works, we'll delete it all and start from scratch. Ooh, it pains me to do so, but I think we can do it in less than 30 minutes. Let's give it a shot. All right. First thing we need to do is open up our base to create our clock. Inside, we're going to pull in our Ableton Link. Chop. We are not going to use the status channels or the ramp. We're going to go straight for the beat and the tempo. We'll leave the 16th notes out of it for this one because it's just extra explanations. You can figure out how those work later. One thing to mention about this, since this is the very beginning of our signal flow of a patch that's going to get much more complicated, this Ableton Link chop cooks every single frame. If we put it on selective over here, now just to see the difference, now we are cooking every frame. Here we are only cooking when the beat changes or the tempo changes, but that happens less frequently than the beats change. Great. So with that, we'll kind of pull a select and separate the two of these guys. because we need to have a tempo what we want to find here is the the seconds per beat. We need to know that so that we can make an event with that length of time. The expression for that is 60 over the input value. So you've got half a second per beat that tracks. Now we're going to merge all these guys back together. Beat, tempo, expression. We're only cooking on occasion. And we'll drop down and out. All right, that is the components that we need for our time. Now we are going to create another base. This is for our events. And another base for our GLSL. We're going to skip right to the GLSL right now so we can see that everything is working the way we are anticipating with our scripts. So let's drop down to GLSL multi. I just default to these because it's oftentimes you wind up with a lot more than 3 inputs, and this gives you as many as you want. For now, let's put down a slider because I want to demonstrate how we can use a simple chop value to indicate which of these lights are on. We'll do a little bit of housekeeping in the GLSL multi here. We're going to have 32 lights. I'm going to take this and not interpolate anything in the viewer because we want to be able to see independent lights exactly for the value that they are referencing. Cool. Let's make a new uniform on the GLSL multi, and we're going to call it UTime. For now, we'll pull in this value. So this slider indicates how far along in a measure we're going to be. Eventually, this will be changed to reference each individual event we have, but for now, just to show how this is going to work, let's open up the pixel shader. And I'm going to also make this so that we can see it up at the top. 4. All the time. Great. So we have our uniform that we created on the GLSL called UTime. We need to pull it into our pixel shader. The thing about one of the things that makes pixel shader so efficient is the script inside never changes. We are only changing inputs that are up on top of the GLSL multi. In this case, we're going to be changing UTime, but this script never changes. So we need to pull in the float from the top before the main. In this case, our syntax says uniform float UTime. It's pulling this in. And then now inside of the main, we're going to rename that value. Float time equals UTime. Well, let's also set a few different colors since we're here. We'll say C0, Vec3. We're always going to change to alpha being 1 so we can see exactly what the colors being output are on our top. And we're going to call this black. Vec3, 0. Now let's also go in and name 2 more colors. All right, so we've got color 1 as red, color 2 as blue, and color 0 as black. So right now we'll just set color. We'll set the color as Vec4 black and 1. Now we have everything black in here, and we'll say if, now let's also create the offset for each of these pixels. So we're going to name a new float. This is the way that I determine which pixels are handled first in the wave of color. And we'll say vuv.s, that is the x value in this case. Oops. If offset is less than time, color equals red. So now as we fade this in and out, you can see we are pulsing the light from not on to all the way on. But what if in this case we wanted to have like a segment of light that was only a quarter the length of our entire LED bank? Let's make a tail value, a float tail, and we'll say 0.25. Okay. If time is greater than the offset, and offset is greater than time minus tail, cool. Now we have our little strip. But when we go to the very end, if this is a whoosh that lasts a measure and it goes whoosh, it gets to 0, and now it's going to go 0 to black. The last lights are just going to pulse off. But we want those to go through the bank of lights all the way out the back. So we'll say time times equals 1 plus tail. Now we have a pulse that starts off and goes all the way through and ends right as we cross the threshold. The light leaves our field. Very cool. Very, very cool. That is pretty much exactly what we wanted. I also like to set, I call this value an inset index. I just makes for easy scripting for myself when I see it. This is essentially, if you were going to make index value from the tip of your little guide to the back of it. So this was 0 and this was 1. We say float equals offset minus time divided by tail. I think I need to put these in parentheses. And of course, semicolon. Color equals inset color equals mix C1 C2 II. Screwed that up earlier. I had offset minus time. It's actually time minus offset. So now you have from 0 to 1 a mix from red to blue. Kind of a cool effect. You can see how this would be cool to have with your any type of GLSL. You start to get like, oh wow, more and more complex looks. And I don't know. I'm talking gibberish, but you get the idea. I think it's cool. Keep it moving. So now what happens if we want to have more than one pulse or set up to an event? Let's go create the events in the neighboring node. So we'll go up a level back into our events. We're going to select our scripts that we had earlier from clock, 2 periods here. And we're just going to select the beat because we want to do a change every a pulse of light every beat. Always good to put a null in the chain at the end, and we'll do a chop execute. Put down an event chop. And if you're unfamiliar with an event chop, the way this works is it creates a ADSR for every time it's triggered. And I'll just show you from the very basic. When I click this button, you get 1 duration of what is programmed here in the event chop. I'm going to get rid of the things we don't need because really for today we're only using ADSR. Clicking in here, what we want to have happen now is the ADSR to go up for the duration that we are determining and then immediately back down. So we don't want any decay time, sustain time, none of this, all zeros. Now when I click it, it goes up for 1 second and is off. But we want to be able to change these robustly through our TouchDesigner chain. And in that case, we are not going to use a button. We're just going to use this chop execute here to send directly to the events. So on value change, our target is going to equal event 1. Now, you will see with the way that this is scripting, every time the beat is triggered, it is sending a 1 second attack time. But perhaps we want to send exactly the number of seconds it takes for a second per beat. So we'll say SPB equals now you can see we have 4 samples here because it's happening quarterly and each of the beats lasts, each of the pulses lasts exactly 1 beat. Oh, I don't even have SPB in here. It's not working because I didn't call it right. I forgot to rename it here in the clock. Oh, I've got this error here where it's not letting me, it's like resending the positions unless I have this on maximum screen. I'm using the alpha version with the new pop operators right now. And that reminds me that there's a pop DMX in the pipeline. Seems like it's going to be a really great upgrade for some of these methodologies. But for now, this GLSL has been working tried and true for me for several years, so it's good to know in any case. Rename. Oops. Rename. And we want to call this SPB. Okay, back to where we were. Now this is actually showing correctly. Quarterly, the beats last for 1 beat. If I come in here and say times 2, and we'll say attack time now you see each of these is lasting for 2 beats, so we have 2 samples in our chop. Now let's customize this event component so we can kind of change these all in one place. We know we're going to need a period. We're going to change the way we sort the pixels. We're going to change the way the colors work. And maybe we'll change the tail. So now we have 4 parameters up top. I'm going to turn this into our parameter. Why can't I read this very well? Okay, here's all of our parameters here. We'll say our period is going to be 2. Our tail will be 0.25. I'm going to delete this button. We don't need this. Pull the parameters from up above. But we don't want period in here because we're going to use that inside of the script. Now if I pull these into the third input here, it's called sample. And every time these are entered, the associated sample retains those values throughout, so we can call them inside the GLSL. Back to our chop Python script here. In our period, we are no longer using 2 as our we're going to use the parent parameter period, which is right here. Events, parent parameter period evaluated. And now if I change this to 8, you'll see a bunch more samples on here because they're all lasting a lot longer. And yeah, there you go. So now we have our events created, and from here we need to pull these directly into our GLSL script. So we'll go back over on the right hand side to our GLSL. In this case, just for simplicity here, we'll pull in another select, make this an out. And we'll pull this out into the select. Apologies for not being able to make these move very well. This is done. Okay. Pulling in the select here, as always, add a null. And now we are going to use an array. Arrays are, hold that thought. We just got sabotaged by ADD, and I never explained what an array was. We use arrays to dissect each of these chops into individual events, and then use each channel of the event to modify our GLSL. The first sample gets evaluated, then the second sample gets evaluated, and then the third sample gets evaluated. All of the tails are evaluated the same way. All of the ADSR is evaluated the same way, so on and so forth. You can see it in action here when we pull it in as a vec4 into our GLSL script. Oops, that's the wrong spot. The chop goes here, and we're going to call this UADSR. For the first array, I often use the ADSR term because these sort, hue, and tail are kind of likely to change from instance to instance of how you utilize these. But the ADSR is just an easy name to keep it static in your script. So we're going to go back to the GLSL pixel here, shader, and we're going to pull in another uniform. This kind of is called UADSR. And with an array, you need to indicate how many samples you are willing to search through at a time. You could make this number lower, but it's not very expensive to run a couple extra times, and occasionally you'll have up to this many triggers at once. So I just kind of keep it at some square number. Now we need to add an if statement here for each of the samples that are inside of the chop that you're using. In this case, I'm just going to go over to another GLSL function that I've been using to copy and paste this, because I always type it in wrong and then we got to check our work. But this is a big dog script that I use for a larger patch, a little excessive for what we're trying to learn today. But it does have the script that we need. So here it is. Here is our for loop to send us through all of the samples. And we need to have this if statement inside of it. And all of these need to move over one more. So I just copied and pasted what we had been using before. And now we will have to assign all of the individual variables to each of the samples coming across the event chop. In this case, what's happening, each one of these samples will be evaluated with the ADSR, the sort, the hue, and the tail, and then added accumulatively into our GLSL. So we're going to use the same variables that we already have up top. We'll say tail equals UADSR I for the sample that we're evaluating, dot R, because it's the first channel in our vec4. And then our next channels are our sort, our hue, and our tail. So let's just go skip straight to tail because we haven't incorporated any sort or hue yet. And we'll say, oops, and this is actually time, not tail. Screw that one up. Tail is our last one. Oop, and we forgot to add our use samples into our vector. So this is going to be the length of this chop. So let's just put an info on here. And we'll pull our length directly into our samples. Still coming up with an error. Oh, and let's also include it as a float. Uniform float int use samples. Boom. And we need to make this a vector 4. Okay, there you have it. Bunch of colors added on top of each other. And what do we need to do? Well, first of all, let's go and change this period to something that's a little more legible. We'll make it 2. And as you can see, the colors are just ending at the it doesn't escape the screen. So we need to add one more thing here. Time equals 1 plus tail. All right, and now it is behaving as we would expect. Got some visitors here at the studio, so take a little break, and I will be right back. All right, a quick trip to the airport, and we're back in business. So here we have our script as we have it, all going left to right. Now let's sort the pixels a little bit. And so we need to add a couple more values in here. We'll call this sort value, that's the second one, so that's G. And then lastly is hue, which is B. Double check that here to make sure we are correct. And yes, we have ADSR as R, sort as G, hue as B, and tail as A. So if we want these to be ints, we need to declare them as integers because they come directly off of the array as a float. Save that. Still working as we anticipated. Now we're going to change the offset of our pixels based on the sort value that comes from our custom parameters. If sort equals 1, offset equals 1 minus vuv.s. Cool. If sort equals 2, offset equals 2 times vuv.s minus 1 absolute value of that. Okay, so now currently our sort is set to 2. It's coming from the middle going out. Our sort is set to 1. It goes right to left. And if our sort is set to 0, they go left to right. Sweet. That's exactly what we wanted. I think this is a pretty good spot to wrap up for right now. We can continue going with hue and change these to kind of have a logic tree for if you want, for instance, blue in front of red or red in front of blue, or you could have all sorts of color combos here for the mixes. You can use the inset index here to add deviation. One more thing real quick. Let's just set up a way to include a special curve. And I actually already plugged it in while I was on pause just to go through a little my next step. But here we have an ordinary ramp that is 1 pixel tall and 256 pixels wide. I'm going to put this white in here to kind of like give the alpha perhaps like a fade in and fade out as we're leaving the inset index. So here, I'm just going to plug this in. Nothing happens, but every script, when you have a new GLSL, includes this line right here for the texture. First input texture 2D. It's just a map of whatever input it is. So in this case, we'll pull this in, and we're going to multiply it here by the inset index. So we'll say inset color is multiplied by the first texture, but we don't want to use this VUVST. We want to make it a vec2 because VUVST is a vec2, but we want inset index. And then we're just going to use the middle of the, oops, and I screwed it all up. What did I do? Middle of the pixel. All right, we're looking at pixel 40, row 40. Can't go from vec 4 to vec 3. So we got to go RGB. And now we have it there. So to demonstrate what's happening, I'm going to move around this ramp. And if I pull this all the way back, you can see we are losing alpha in the front. Or put this back to the, we are controlling the fall off inside the inset index. And so you can have a 3D texture top of tons of these ramps. RGB, each color is independent, it's really fantastic how you can use curves like this. I have maybe 24 curves that I'm kind of like shifting between from time to time. Some are like with a really substantial attack and then a really long release. Some of them are sine waves, so on and so forth. You can get really creative. It's all up to you. But anyway, that pretty much wraps up what we wanted to discuss for like the basic building blocks of how we are building out a time-coded show with any type of DMX fixture. Just for clarity, we'll go one step further and show you how you can shuffle these pixels to send it out straight like an NTEC dongle. That's what we're using to push all of our colors through all of our lights. So here we have RGBA. We don't want A. And then we're going to shuffle. And I think we want to sequence all channels. No, that's not right. Sequence all samples. Yeah, that's what we want. So that is giving you RGB like a serial output that you can now take to a DMX out chop. It's going to give me an error because we don't have any units hooked up. But if we do packet per channel, you can send this directly off of one universe. If you need more universes, you can split it up every 512 channels. Lots of fun to be had figuring that out, but we can get there on the next one. Appreciate everybody listening. Hope you learned a little bit of something. Hope I got some tips and tricks in there because, I don't know. I think some of them are fun. Anyway, if you have any questions or updates or you think I can do something better, please let me know in the comments. Really excited to hear more and learn more, and I'll cook up another one of these in a little bit. Thanks a lot. I'm Scott with 2Bays. Peace.